The River Wye is of high conservation value. It is designated a site of special scientific interest and also a special area of conservation. Consequently, it's really important that we have the right interventions in place to bring the river back to the health it once was. Our data and evidence informs us that approximately 70% of pollution of the River Wye comes from agriculture, approximately 20% from the water industry. Consequently, we're prioritising our agricultural regulation in parts of the catchment where we see there'll be the most benefit to water quality. We also know that climate change is happening, and we need to recognise that what interventions we make now have to be safeguarded for the future. The Environment Agency firstly build on the data and evidence, which is why we're working with the team at Lancaster University. Data and evidence enables us to ensure we have the right intervention in the right place. We also do a number of additional monitoring for the Wye in terms of water quality alongside citizen science. What that means is that we have a true picture of what is happening across the catchment. The reason why we're working with the team at Lancaster University is understanding the role of phosphate within the catchment, how it moves, but also the role of legacy phosphate.
Well, really, phosphorus is absolutely fundamental to life. It's a part of our bodies, it's a part of our DNA, it's part of our bones, part of our structure. Without phosphorus, there is no life. From an agricultural perspective, our crops need phosphorus to grow and yield successfully. So they require additional phosphorus inputs in fertilisers and manures. Just like us, our livestock, they need to eat phosphorus for healthy growth and development. So we must make sure our livestock in our food systems have adequate nutrition. So yeah, it's really it's one of the building blocks of life. Phosphorus is a mined element. It is a finite resource, and we're totally reliant on imports. So that's the food resilience aspect of phosphorus. The other is the environmental aspect of phosphorus. So when it's poorly managed in our food systems, and it in particular gets into our freshwater ecosystems, it can be quite environmentally damaging. I mean, we know the Wye catchment has actually been in surplus for a long time. The historic analysis that we've done shows there's been a surplus in the catchment going well over 100 years. So there's been a continual build-up of phosphorus in the Wye landscape, and we've looked at some of the soils in the Wye, in particular the English part of the Wye, and we know that many of those soils have quite a low capacity to absorb or hold on to that phosphorus. So if we load those soils with phosphorus, we know the chances are they could be a little bit leaky, so let some of that phosphorus out. The other aspect of the Wye soils is many of the soils are quite silty and sandy, so they can be prone to erosion as well, which is another way that the phosphorus can leave that soil. So in many ways it's a little bit of a perfect storm, in that we have a phosphorus surplus in the agriculture in the Wye, and the soils and the landscape come together to make, I guess, quite a risky landscape for high phosphorus pressure. The principles of soil nutrient management start with soil testing, so you know your starting point, you know what the phosphorus levels are in your soil, you know what crops you are growing, so you can predict what your phosphorus offtake will be in your crops and your grass. So your decisions about phosphorus input will always relate to the soil status and what you're predicted to offtake in your crops. The fundamental challenge we have is where we have large populations of intensive livestock, we have a lot of pea-rich manure, and then we don't necessarily have the crop or grass demand for it. So we often find ourselves in situations where the manure is going on the land, and therefore the phosphorus is going on the land, but actually there's more going on than is actually required for the growth of the crops and the grass.
A lot of the research that we've been doing is trying to understand why some catchments are a better sponge to phosphorus than others. So why are some particularly leaky, like the English part of the Wye, which have really leaky soils with not great phosphorus buffering capacity? So when phosphorus is applied, they can really leak that into the river, which makes them really great for growing crops because that phosphorus is very available. And then looking at why other catchments really hold on to that phosphorus, they're a really good sponge and they don't leak much into the river.
And particularly with the soil types, these sandy, silty soils with a low phosphorus buffering capacity, we were asking the question, is some of that phosphorus actually migrating down deeper into the soil profile? So this is the next piece of work we're going to do with the Environment Agency, and we're actually sampling down to 90 centimetres depth and analysing for phosphorus deeper in the soil profile.
You know, we always think of phosphorus as being in the top 20, 15 centimetres of the soil, and that's where farmers will do their soil testing. But we're going to have a look at to see whether there's phosphorus migrating down the soil profile, especially in these sandy soils, to see whether you're then potentially at risk of subsurface leaching or leaching through land drains.
I mean, collectively people can come together and start to think, okay, how do we take that pressure off the landscape? And I think a really important point and a really important message that we're trying to get across, that this is not just a farmer challenge, it's a food system challenge. So collectively, everyone involved in that food system needs to come together to think about how do we relieve the pressure on this landscape.
It's important to recognise that everybody wants the same thing: improve water quality and good river health, and only working together will we address the problems of the past in order to ensure that happens in the future. And we have a web space called Riverway Engagement HQ, which can be found online, where you can find some of the information around what we're doing in the catchment, but also some of the interpretation around what those findings mean.